Welcome to Cosmos and a Pod Space and Astronomy series. Today, we're taking a deep dive into a truly awe-inspiring subject, and
Yeah,
that's spiral galaxies.
we really are something else.
Imagine just a swirling, glittering city of stars and gas and dust spanning hundreds of thousands of light years.
It's hard to wrap your head around it.
Yeah, it's difficult to grasp,
It really is.
but that's a spiral galaxy, and one of them, the Milky Way, is our home.
Our home, and not just any home, it's a dynamic and evolving one.
Hmm.
These grand structures, they're shaped by fundamental forces we're still trying to fully understand, like gravity, the enigmatic influence of dark matter, and even collisions with other galaxies.
Collisions.
Yeah,
That sounds intense.
yeah.
I always pictured galaxies as these serene, almost static objects.
Right.
So how did these collisions and these mysterious forces shape the galaxies we observe?
Well, first let's define what makes a spiral galaxy a spiral galaxy. Imagine a flat disk rotating gracefully like a cosmic record player, but instead of grooves, picture brilliant, sweeping spiral arms spiraling outwards from a bright central bulge.
That's an image that never gets old.
Oh,
Those elegant, almost artistic spirals against the blackness of space.
right. And these arms, they aren't just for show.
Okay.
They're hotbeds of star formation, where clouds of gas and dust are compressed, igniting new stars and dazzling displays of cosmic fireworks.
So these arms are constantly churning out new stars. That's incredible. But if these arms are constantly moving, why don't they just fade away over time? How do they maintain their shape?
That's where the concept of density waves comes in. Imagine ripples in a pond, but on a galactic scale.
Okay.
These waves move through the galaxy, compressing the gas and dust as they pass. This triggers bursts of star formation, lighting up the spiral arms. It's almost like a cosmic traffic jam, causing pileups of matter and igniting a wave of stellar births.
That's a great analogy. I can almost picture those waves of density sweeping through the galaxy, leaving a trail of newborn stars in their wake. But how do these waves even get started? Is there a galactic speed bump out there causing these ripples?
That's a question that has puzzled astronomers for decades.
Okay.
Some believe these waves are triggered by gravitational interactions with other galaxies, like a cosmic nudge that sets those ripples in motion. Others propose they arise from processes within the galaxy itself, perhaps related to the rotation of the central bar or the distribution of mass.
So it's still a bit of a mystery. We're not entirely sure what sets those galactic waves in motion, but either way, it results in those stunning spiral arms we see in so many galaxies.
Exactly. And to make things even more interesting, those bright, massive stars born in the spiral arms have relatively short lifespans. They burn through their fuel quickly, eventually exploding as supernovae.
So it's a constant cycle of birth and death playing out across these vast cosmic canvases.
Yeah, it's pretty remarkable.
But you mentioned something about galaxies colliding. How does that fit into the picture?
When galaxies collide, things get really interesting. The gravitational forces involved can distort their shapes, trigger intense bursts of star formation, and even merge them into something entirely new.
So instead of a serene cosmic ballet, it's more like a chaotic mosh pit of stars and gas.
In a way, yes, it's a dramatic process that can completely reshape a galaxy. Spiral galaxies can be transformed into elliptical galaxies, which are more rounded and lack those distinct spiral arms. It's almost like a cosmic remodeling project, taking these elegant structures and morphing them into something else entirely. And speaking of collisions,
Oh,
our Milky Way is on a collision course with our neighbor, the Andromeda Galaxy.
hold on. You're saying our galaxy is going to collide with another galaxy?
Yeah.
When is that happening?
Yeah.
And what's going to happen to us in our solar system?
Mark your calendars. It's in about 4.5 billion years, but
Yeah.
don't worry too much. The vast distances between stars mean it's unlikely our solar system will experience a direct collision. However, the gravitational interactions will dramatically reshape both galaxies, triggering intense star formation and possibly flinging stars out into intergalactic space.
4.5 billion years is a long way off.
It is.
But that's still a pretty wild thought.
Yeah.
So our galaxy, which we see as this constant familial presence in the night sky, is actually in constant motion, evolving over billions of years and eventually colliding with another galaxy. It puts things into perspective, doesn't it?
Absolutely. And it's just a taste of the complex processes that shape these magnificent structures. But to understand them fully, we need to delve into one of the biggest mysteries in modern astronomy, dark matter.
Dark matter. That sounds pretty intimidating. I
Right.
know it's something we can't even see,
Right.
but it somehow plays a crucial role in how galaxies behave.
It does. You see, astronomers notice something strange about the rotation of spiral galaxies. The stars in the outer regions were moving way faster than they should based on the visible matter alone. It's like something invisible was giving them an extra gravitational kick.
So it's like a phantom hand guiding those stars.
Exactly. Astronomers theorize that a massive halo of dark matter surrounds each spiral galaxy, providing the extra gravity needed to explain those super-fast stars. It acts like an invisible scaffolding holding the entire structure together.
That's incredible. So this invisible stuff is actually holding galaxies together. It's like the glue that keeps a whole cosmic structure from flying apart.
Yeah, it's pretty amazing.
But if it's invisible, how do we even know it's there? How do we discover this dark matter?
It's a fascinating story, and one that has revolutionized our understanding of the universe. It all started with those observations of galaxy rotation. But to fully grasp how we know dark matter is real, we need to delve into the evidence, and that's where things get really exciting. It all boils down to gravity. You see, we know how much visible matter, stars, gas, and dust exists in a galaxy. And from that, we can calculate how much gravity should be present. But when you look at how fast those outer stars are whipping around the galaxy, it's like they're being influenced by a much stronger gravitational force than the visible matter can account for.
So it's like watching a car take a corner way too fast.
Yeah.
You know, something must be holding it on the road, some invisible force preventing it from spinning out. And in the case of galaxies, that invisible force is dark matter.
Precisely. And it's not just galaxy rotation.
Yeah.
We see evidence of dark matter's gravitational influence on a much larger scale, affecting how galaxies cluster together and even bending the path of light as it travels through the universe. It's like an invisible web holding the entire cosmic structure together.
It's mind-boggling to think that something we can't see makes up such a huge portion of the universe. But if dark matter is so crucial,
Yeah.
how did these spiral galaxies form in the early universe, when the universe was denser and dark matter would have been more evenly distributed?
That's a great question, and one that pushes at the boundaries of our current understanding. It seems that even in the early universe, when things were more chaotic, dark matter still played a key role in seeding the formation of galaxies.
So even in that cosmic soup of the early universe, dark matter was acting like a shepherd gathering matter together to form those first galaxies.
It's a good way to think about it.
And were those early galaxies all spirals, or were there other types of galaxies back then?
Well, those early galaxies were smaller and less structured than the majestic spirals we see today. Recent observations suggest that spiral galaxies might have been more common in the early universe than we previously thought.
Really, I thought the early universe was thought to be more chaotic, with galaxies colliding more frequently, resulting in those less defined elliptical galaxies.
That's what astronomers believed for a long time, however. With powerful new telescopes like the James Webb Space Telescope, we're getting clearer glimpses into the early universe, and those observations are challenging our assumptions. We're seeing more evidence of early spiral galaxies, suggesting that the conditions for forming these organized structures might have existed much earlier than we thought.
So spiral galaxies aren't just a recent phenomenon. They've been part of the cosmic landscape for a very long time, influencing the evolution of the universe itself.
Absolutely, but as we've discussed, they're not static structures. They evolve, they interact, they collide. And speaking of collisions, we can't forget that our own Milky Way is on a collision course with the Andromeda Galaxy.
Right, that's a pretty big event in our galaxy's future, but
Yeah.
is it just a one-off, or are these collisions common occurrences in the life of a galaxy?
Galactic interactions and mergers are surprisingly common. In fact, many of the spiral galaxies we see today likely formed through mergers with smaller galaxies. These mergers can trigger bursts of star formation, reshape the galaxy's structure, and even strip away gas and dust, leaving a more quiescent galaxy behind.
So it's like a cosmic dance with galaxies constantly interacting, merging, and changing over billions of years.
Yeah, it really is.
But what happens to a spiral galaxy after all the action dies down? What happens when it runs out of gas to form new stars?
That's a great question. As the gas supply dwindles, star formation slows down, and the galaxy enters a quieter phase, the brilliant blue hues of young stars fade, giving way to the reddish glow of older stars. The spiral arms become less prominent, and the galaxy gradually transitions into a more settled state.
So like a cosmic retirement party, the galaxy winds down, the lights dim, and things get a bit, well, less exciting, but
Right.
could something jolt it back to life even in this quieter state?
That's right. And while this might seem like the end of the story, the universe is full of surprises, even in their twilight years. Galaxies can experience unexpected events, interactions with smaller galaxies, or even the influence of dark matter can stir things up, triggering new bursts of star formation or altering the galaxy's structure.
So even in their golden years, galaxies can still have a few tricks up their sleeves. It's incredible to think that these grand structures are in constant flux, shaped by forces we're still trying to fully comprehend, and we've only just begun to scratch the surface of understanding them.
Yeah, it really makes you appreciate the sheer scale and complexity of the universe, doesn't it? We've talked about density waves, galactic collisions, and the invisible hand of dark matter.
Oh, yeah.
But I'm guessing there are still plenty of mysteries swirling around these spiral galaxies.
Absolutely. For example, we've touched upon the idea that spiral arms might be triggered by interactions with other galaxies, but there's also the possibility that they arise naturally from processes within the galaxy itself.
So it's a bit of a chicken or the egg scenario. We're not sure if those spiral arms are caused by external nudges or internal dynamics.
Exactly. And then there's the question of how those spiral structures are maintained over billions of years. Those density waves are constantly moving, so why don't the arms just dissipate over time? It does seem counterintuitive. If it's all just a wave, you'd think those arms would eventually just fade away.
Right, but something keeps those waves going, something keeps those arms defined, and that's where the interplay of gravity-gas dynamics and star formation gets really intriguing. It's a complex dance that we're still trying to fully decipher.
It sounds like there's still so much we don't know about these majestic structures. Where do we even begin to tackle these questions? What are the next steps for astronomers studying spiral galaxies?
Well, as we mentioned earlier, the James Webb Space Telescope is already giving us unprecedented views of the early universe. Being able to see those early galaxies, those baby spirals in the process of formation, is providing invaluable insights.
It's like having a time machine, allowing us to see how these spiral structures first emerged. Are there any other tools or missions on the horizon that have you excited?
Absolutely. The Nancy Grace Roman Space Telescope is set to launch in a few years, and it will have a wide field of view, allowing us to survey vast areas of the sky and study the distribution and evolution of galaxies in unprecedented detail.
So it's like having a panoramic view of the cosmos, letting us see the bigger picture of how galaxies are born, how they change, and how they interact with each other over billions of years.
Precisely. And then we have the Square Kilometer Array, a radio telescope that will be the largest and most sensitive ever built. It will be able to detect incredibly faint signals from the early universe, essentially giving us a glimpse into the cosmic dawn when the first stars and galaxies ignited.
Feels like we're on the verge of a golden age of astronomy with all these incredible tools at our disposal. What are some of the big picture questions you hope these new discoveries will help us answer?
Some of the most fundamental questions about our universe. How did it all begin? What were those first galaxies like? How did the universe evolve from that early chaotic state to the structured cosmos we observe today? And perhaps most importantly, what is the ultimate fate of our own cosmic home?
Big questions indeed. But questions that spiral galaxies, these intricate and enigmatic structures, might hold the key to answering. It's been a fascinating journey exploring these cosmic wonders, from their elegant spiral arms to the mysteries of dark matter and the drama of galactic collisions.
It has, and it's a reminder that we are part of something truly awe-inspiring, a vast and intricate universe that's still unfolding before our very eyes.
So the next time we look up at the night sky and see those faint smudges of light, those distant spiral galaxies, we'll know that they're not just pretty pictures. They're cosmic time capsules, each one a story of star birth, galactic evolution, and the enduring mysteries of the universe.
Exactly. They're a testament to the beauty, complexity, and enduring wonder of the cosmos.
Well, I think that wraps up our deep dive into the fascinating world of spiral galaxies. If you want to continue exploring this topic, there are some incredible resources available online and in libraries.
And of course, we encourage you to follow and subscribe to Cosmos in a Pods podcast and YouTube channel for more fascinating insights into space and science.
That's right. We're constantly exploring new topics, interviewing experts, and bringing you the latest discoveries from the world of astronomy and beyond. So until next time, keep looking up, stay curious, and never stop exploring the wonders of the universe.